All right, so let's take a look at this second one, which is the 8-3 notes, page 7. And so this is where we finished off last time. We talked about how do we prove something is a parallelogram. We have if the sides of both pairs are congruent, it's a parallelogram. Both angles are congruent, it's a parallelogram. If the diagonals bisect, it's a parallelogram. And then if one pair is both congruent and parallel, it's a parallelogram. And then we answer these questions, and that's where we finished off. So let's go ahead and prove a couple of these, but first let's turn to the back page. Just answer some of these pretty quickly. So what would make this a parallelogram? Okay, so for example, what value of A would make this a parallelogram? Well, obviously that would be 70, right? Why? Because then opposite angles would be congruent, right? Anything besides 70, opposite angles wouldn't be congruent and it wouldn't be a parallelogram. Okay, what value of X would make this a parallelogram? Let's see. Well, if x was 9, right? Because 9 plus 1 is 10, and if that was 10, then and only then the opposite sides would be congruent, right? If opposite sides are congruent, then I know it's a parallelogram. So again, we're just kind of reversing it and saying, how do I prove it's a parallelogram? Right? What value of y would make this MLNP a parallelogram? That would be 6, right? If y equals 6, right? If y equals 6, this, sorry, not 6, but if y equals 5, then it's a parallelogram because we have, then this would be 10 and 10, right? Because then the diagonals would bisect each other, right? The diagonals would bisect each other. Okay, so let's see. Find the values of A and C, so we'll do 12 together, and then try 13 on your own. Find the values of A and C to make this a parallelogram. Well, if this was to become a parallelogram, this would have to equal this, right? It would have to, so let's just set them equal. Okay, we're just going to go ahead and solve algebraically, so we're going to subtract C from both sides. So 2C minus 3 equals 1. We're going to add 3 to both sides. So 2C equals 4, so C equals 2. So in other words, if C equals 2, I plug this in here, 2 plus 1, this would be 3. Plug this in here, 6 minus 3, this would also be 3. So C equals 2 is the only value. C equals 5, C equals 7, C equals 1. None of those make opposite sides congruent like that. All right, now for the value of A, it's a little bit trickier. Again, we don't have, these are not opposite angles. We do not want to set these equal. That doesn't make any sense because then you're going to get 0 equals 40. Remember, if it's a parallelogram, this is going to be supplementary, right? Same side, supplementary. So what we want to do instead is want to say A plus 40 equals 180. Okay, A plus 40 equals 180. So we get 2A plus 40 equals 180. Subtract 40 from both sides, we get 2A equals 140, and so A equals 70 is the value that works. A equals 70. Plug that in here. If that was true, this would be 70 degrees here, and this would be 70 plus 40. 70 plus 40. That would be 110. And you can see, yes, that would be same side, supplementary. All right, so to finish up, trying to figure out yourself what values of x would make this a parallelogram. It looks like we've got different variables here, but I think you can work with that. So try that problem on your own. All right, so let's continue to the next page here. We're going to do number 14 here. Number 15, this was on your homework, the previous homework. This was number 38 or something like that. So this is, you don't have to do this, just make sure you tried it on your homework and maybe you'll understand it better now. You can go back and do it and I'll take a look at it on Friday. So homework from the previous homework, number 38. So we're going to do number 14 and we're going to do number 16 partially, and you can skip 17 just for time's sake. So we'll just do 14 and then 16. All right, so let's make a proof that if opposite sides are congruent, then it's a parallelogram. Again, notice the difference. It's the reverse, it's the converse. I don't know it's a parallelogram. I need to show it's a parallelogram. So I cannot put the little arrows here. All I know is that opposite sides are congruent. So we can put tick, 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 tick. We cannot put the arrows. So this is all we know. So let's go ahead and write that. AB is congruent to CD. AC is congruent to DB. That's all we know. Okay, so the hint for this one is kind of like the other ones. We just want to take it and turn it into something we can work with. So let's go ahead and draw this diagonal here. And if we can, let's just prove these two triangles congruent and see what comes out of that. Take a look, and I think we can see that this one is shared by these two. That's one that we like to get a lot, and no problem. We'll just write it out. AD is congruent to AD, again, by the reflexive property. You are congruent to yourself. Okay, and we can see now, yes, I've got these triangles all set up. I could say triangle ABD. Triangle ABD is congruent to triangle DCA, right, by SSS, right, SSS. Okay, you might be saying, well, why does that help us at all? Because once I've got that, notice that because the triangles are congruent, I can now say all of the parts are congruent. Right? I could say these two angles here, but that's not as helpful. But watch what happens. I could say this angle here, angle CAD, is congruent to this angle here. So I'll say angle CAD, let's do it in red, CAD is congruent to BDA. Just put a comma here. And also this angle here, double arc, is congruent to this angle here. And so that would be angle CDA is congruent to angle BAD. All right, and those are, again, those are alternate in, sorry, not alternate interior, excuse me. There's my mistake right there. That's not alternate interior. That is because I've proven these triangles congruent, so I can say these parts, these corresponding parts. So corresponding parts of congruent triangles are congruent. So that was my mistake right there. You cannot say alternate interior angles, because we do not know that they are parallel. But here's the thing. Since I have just proven these congruent, right, these are alternate interior angles. I don't know they're parallel, but if you think back to chapter 3, we actually had the reverse as well. Remember, the original of the alternate interior says if they are parallel, if the lines are parallel, then alternate interior angles are congruent. But what we have here is the converse. The converse says if alternate interior angles are congruent like this, then I can say the lines are parallel, right? It's just the reverse. If alternate interior angles are congruent, then I can claim the lines are parallel, and that's exactly what we have here. Look at these alternate interior angles. So because of this, because alternate interior angles are true and congruent, excuse me, I can say that this is parallel to this by the converse of the alternate interior angles theorem. So I can indeed say that AB is parallel to CD, right, by the converse of alternate interior angles. But not just that, if you turn your paper kind of sideways, you can see also that these are also alternate interior angles. Sorry, these right here. So this and this. So this also is going to be parallel to this, right? Because these alternate interior angles are congruent. So I can also say that AC is parallel to BD. And look, now I've given parallel, parallel, I've got the definition of a parallelogram. So I could say parallelogram ABCD. Right? I could say ABCD is a parallelogram. Why? Because both pairs of sides are parallel. Right? You can say, that's the definition. So we proved it. So we used the converse of the alternate interior angles theorem. Again, 15, this was on the homework. You can skip that. Very similar strategy. Try that. 16, and we'll start it off together, and then you can finish it. So same idea, except this is that one that's not a converse of anything. It says if you have one pair of opposite sides, both congruent and parallel. So go ahead and put a tick, tick. There's the congruent. And then arrow, arrow, parallel. So just one side. Let's prove it's a parallelogram. Okay, so all we know, AB congruent to CD. And AB is parallel to CD. Okay, so try and do the same thing. Let's go ahead and draw. Oops. Draw on this guy here. Okay. And so the same idea is going to hold. So if you have parallel lines, think about what you can add. Try to prove these two triangles congruent. Once you have proven these triangles congruent, add in everything by CPCTC, and then you can use the same idea, the converse theorem. So again, if you have alternate interior angles congruent like this, then you could say that the lines are parallel by the converse of alternate interior angles. So first, here's my hint, prove the triangle's congruent. Use the fact you have parallel lines. Once you got the triangles congruent, add some stuff by CPCTC, and then you could use the converse theorem like we did here. See if you can prove that this is a parallelogram. In other words, you need to find a way to get these parallel. How do you get these parallel? Use this converse theorem to get there. All right, try your best.